Hello everyone, this side Aniket Kumar from NIT Patna, and now I'm gonna teach you a very famous and interesting topic, projectile motion in physics. So the topic is projectile motion. So before moving further, I should tell you the objective of this lecture. So first of all, we will have a brief discussion over definition and the types of projectile motion, and we'll discuss some very good example in our day-to-day life, like if you kick a football, it's also a projectile motion. If you throw a javelin, it's also a projectile motion. So now deeping dive into the definition. So what is projectile motion? So basically in the layman term, we can say any motion under the influence of gravity that follow a specific trajectory, that is parabola, is called projectile motion. Here is a good diagram of projectile motion. Let's suppose a ball thrown at an angle theta with some velocity v. Here is the x-axis, here is the y-axis, and the ball will follow this trajectory, will land at this point. The velocity here is v, so bifurcation into x-axis and y-axis. So in x-axis the velocity is v cos theta, and in y-axis is v sin theta. This is the topmost point where the vertical velocity will be equal to 0, means ball will be thrown, and at that point the velocity in y-axis will be equal to 0. So this is the maximum height attained during the projection, during the trajectory. The important characteristics of projectile motion is that in x-axis there is no any such acceleration. So if acceleration is 0, the velocity will be constant. So if at this point the velocity in x-axis is v cos theta, so at this point v cos theta, at this point v cos theta, at this point v cos theta. But the vertical velocity will change because gravity is there. Gravity play a very crucial role in this projectile motion. So the basic terms also uses in this projectile motion is like a range. So what's the range? Range is actually a horizontal displacement in x-axis. This is the height attained during this trajectory, the time period elapsed during this trajectory. We will have a brief discussion over the formulas and over the terms used here. So now deeping dive into the types of projectile motion. So basically there are two types of projectile motion. First is horizontal projectile motion, and second one is angular projectile motion. I will tell you with a good diagram. This is a vertical wall, this is the ground, and if a ball is thrown with some angle, with some velocity v in x direction, so the ball will follow this trajectory and will land at this point. But the velocity in the y-axis will be equal to 0 here. Gravity is obviously here, so gravity will influence this velocity, and velocity will eventually increase and will reach at this point. So this is the horizontal projectile motion. And what's about the angular projectile motion? As the name suggests, angular, so the ball will be thrown with some angle, let's suppose theta, with some velocity v. So the ball will follow this trajectory and will land at this point. If the velocity is v here, I already told you the velocity in x direction will remain constant. So velocity at here is v, here is v. If the velocity is v here, so bifurcation of this velocity in x-axis is v cos theta, and in y-axis is v sin theta. At this point, velocity in y-axis will be equals to 0, and this will be the maximum height attained. Okay, I think it's clear. Now deeping dive into the horizontal projectile motion, and after that we will focus on angular projectile motion. So I also told you 3 terms in projectile motion. First of all, the time period, second is range, and third is velocity at any point of time of the trajectory. So before calculating these terms, let's have a recall of 3 important formula of motion. That is, first, v is equals to u plus at, second is s is equals to ut plus half at square, third is v square equals to u square plus 2as. These all 3 formulas are valid only for uniform acceleration. So now calculate time, then range, then velocity. So for time calculation, here we know h is the height attained. So which formula to use to calculate time here? I think the second number formula will be good here, because we know the displacement h here, u is the initial velocity, that is 0. So let's use the second formula. S is equals to ut plus half at square. But it's a very good need to know, like here we are taking the below direction is positive and the above direction is negative. It's actually very crucial to have a look for the calculation part. So here the displacement is h here, so s is equal to h. Here the initial velocity will be equals to 0. Half into acceleration is here gravity g t square. Therefore t will be equals to root under 2h by g. So time period is calculated. Now what about the range? It's very simple to calculate range, because we know the displacement is equals to velocity into time period. So range is here this one, and we know in this direction velocity is v, and we know the time period here. So the range will be equals to v into root 2h by g. It's easy. What about the velocity at any point of time? Let's suppose this point. So let's suppose the vx is the velocity in the x direction and vy is the velocity in the y direction. So what's the actual velocity here? In this direction, let's suppose capital V is equals to over root v of x square plus v of y square. This is the velocity at this point of time. So we have calculated the time, range, velocity. I think, are you getting all this? Now the second type of projectile motion, that is angular projectile motion. In the angular projectile motion, we know the object is projected with some angle theta, and after that I will also tell you a very good scenario where the athlete used this concept. Let's suppose a ball is projected with angle theta with velocity v, and follow this trajectory, will land at here. So at this point is the maximum height attained, that is h. Here is the range, and bifurcation of the velocity in x-axis is v cos theta, in y-axis is v sin theta. So for time calculation we will use second number formula here. So s is equals to ut plus half at square. But what's the actual displacement here? The ball is thrown from the ground and returning to the same level. So the actual displacement is here is 0. Ball is going here and there and then again to the same level. So the displacement is equals to 0 here. What about the initial velocity? V sin theta, but in upward direction, means negative of V sin theta into t plus half. Acceleration is here is g, half gt square, and now it's simple mathematics. 0 is equals to minus v sin theta plus half g t. So 2v sin theta upon g equals to t. I think it's correct. 2v sin theta upon g equals to t. Yeah, the time period is simply calculated. Now about the range, it's actually very simple. Just v cos theta into time elapsed during this projection. So the range will be equals to v cos theta into time period here is 2v sin theta by g. 2v sin theta by g. और मैं बता दूं कि फिजिक्स में बेहतर होने के लिए मैथ्स में बेहतर होना बहुत ज़रूरी है, नहीं तो कॉन्सेप्ट सब आएगा, मैथ्स नहीं आएगा तो फिर रिजल्ट 0 आएगा. So here the simple mathematics, 2 sin theta cos theta, we all know sin 2 theta. So here sin 2 theta into v square upon g. We will hold this formula for a while. We will have a good example over range. What about velocity is actually very easier to calculate. At this point, velocity will be in the x direction here, velocity will be y direction here. At this point, velocity in x direction is v of x, in y direction v of y. So here velocity will be equals to v of x square plus v of y square ka over root. Here the velocity is equals to over root of v of x square plus v of y square. So time, range and velocity is calculated very easy. Yeah, I told about a good example over range. So you know Neeraj Chopra, I think you know. If you know Neeraj Chopra, you know javelin throw. So any athlete in javelin throw or a shot put try to have a maximum range for the competition. So for the maximum range, what should we do? We should maximize this. So for this, we should maximize sin 2 theta. And we know the graph of sin theta. I already told you mathematics is very much important for physics. So for sin theta, this is the graph. Here the infinity, here the minus infinity. 0, 1, 1. At this point, pi by 2, here pi. So the maximum value of sin theta is 1. So to maximize sin 2 theta, we should take theta is equals to pi by 4. That's why the sin pi by 2 will be equals to 1. So theta is equals to pi by 4 means 45 degree. So any athlete want to try to throw javelin shot put at making an angle of 45 degree with x-axis to maximize range. I think you're getting all the point. If you have any doubt, just comment in the comment section. Thank you so much.